we have some problems here. Okay, now we have a case. It's asked, in how many ways 3 friends out of 8 can go for a movie? So here we have R is equal to 3, N is equal to 8. So we need to pick up 3 friends. Now the order in which they are chosen is not important, so obviously it's a combination. So it's going to be NCR, which means 8C3, which would be 8 factorial upon R factorial, that is 3 factorial into 8 minus 3 factorial, which will turn out to be 8 into 7 into 6 into 5 factorial upon 3 factorial into 5 factorial. This gets cancelled. Even 3 factorial is 3 into 2. So this gets cancelled. Ultimately, it's 56. So there are 56 ways 3 friends out of 8 can go for a movie. Then we have a case wherein in how many ways 3 out of 8 red and 2 out of black balls can be selected. So this is going to be 3 out of 8. So it's going to be 8C3. And it is not told or, it is and, hence it is and 2 out of 5. So it's going to be 5C2. 8C3 we calculated is already 56. And 5C2 will be 5 factorial upon 2 factorial into 5 minus 2, that is 3 factorial, which will turn out to be 56 into 5 into 4 into 3 factorial upon 2 factorial into 3 factorial. This gets cancelled and you have 2. So it's 56 into 10, 560 ways we can select 3 out of 8 red and 2 out of 5 black balls. This is the way. So 560 selections can be made. So this is a simple understanding of how we can apply the formula. Okay. Now here we have a case wherein number of straight lines obtained by joining 16 points on a plane, which has been given twice. It means no 2 of them being on the same line. It means all these points taken at a time are all non-collinear points. So it's going to be 16 points, 1, 2, 3, 4 and 16 and no 2 of them. So how many such lines you could have? One like this, even this way. So you're going to take 2 out of 16 at a given time and you have to calculate the number of lines. So it will be like a polygon that is going to be formed. So it would include the 16 sides of the polygon and the various number of diagonals. So it's basically the number of lines that can be formed is going to be 16C2 because each line is formed by joining any 2 of these points. This will turn out to be 16 factorial, n factorial upon r factorial 2 factorial into n minus r, that is 16 minus 12, 14 factorial, which works out to be 16 into 15 into 14 factorial upon 2 into 14 factorial. This gets cancelled and you have 15 into 8, which is 120. So we have 120 straight lines that can be formed so that no 2 of them are on the same line. So we have the number of such straight line is 120. Let's check whether it is tallying, and yes, we do have it as 120. Now let's take the next one we have here is okay. The number of triangles that can be formed by choosing the vertices from a set of 9 points such that points are non-collinear points. So we have 9 non-collinear points, and out of these sets of 3 have to be chosen to form triangle. A triangle is formed when you join 3 9-collinear. So you're going to take groups of 3 non-collinear points. So it's basically going to be 9C3. You're choosing 3 out of each of these 9 collinear points and forming triangles. So it is 9C3, which is 9 factorial n factorial upon r factorial 3 factorial into n minus r, that is 9 minus 3, 6 factorial, which can be written as 9 into 8 into 7 into 6 factorial upon 3 can be written as 3 into 2, and 6 factorial is written as it is. And we have 3 3s are, and this is 4. So this turns out to be 84 such triangles are formed. Now, again, the order is not important. Triangle ABC or triangle ACB or triangle BAC or BCA, all are one and the same triangle. Hence, it's not a permutation. It's a clear-cut case of combination. Okay. Yes, and we get that as 9C3. Furthermore, we have, okay, 6 points are on a circle, the number of quadrilaterals that can be formed. So there are 6 points. So we have 1, 2, 3, 4, 5, 6, and you're going to form quadrilateral. That means to form a quadrilateral, you need 4. If they are the idea behind why they are on a circle, to understand that again they are non-collinear points. So the fact that they are not collinear is told in a different way, which essentially, in a sense, it means the same, that 6 points are non-collinear, like the way it was in the previous case. So out of these 6 non-collinear points, you need to check 4. You need to take groups of 4 to form the quadrilateral. So it's going to be 6C4, which will be 6 factorial upon 4 factorial into 6 minus 4, 2 factorial, which will be 6 into 5 into 4 factorial into 2, which will turn out to be 4. And this is 30 by 2, 15. Hence, we can make 15 such quadrilaterals out of this, because it's 6C4, and yes, we do have it as 15. So what we have here is that 8 points are marked on the circumference of a circle. The number of chords obtained by joining these in pairs is what? So if there is a circumference, you have a circle here and you have 8 points, 1, 2, 3, 4, 5, 6, 7, 8. So you are joining them and you get a particular polygon. So the number of chords would be the sides plus all these various diagonals that are involved. So basically you're choosing 2 out of 8. So it's going to be 8C2. So the number of chords is going to be 8C2. So it's going to be 8 factorial upon 2 factorial into 8 minus 2, 6 factorial, which would be 8 into 7 into 6 factorial upon 2 factorial into 6 factorial. And this becomes 28. So there are 28 such chords that can be made using these any 2 out of these 8 points, and hence we have 28 as the right answer. So let's see what we have. Yes, we do have 28. And what do we have in store for the next? Okay, the number of diagonals in a decagon is 30, 35 or 45. Now there is a formula for number of diagonals. It will be the formula for number of diagonals is going to be n into n minus 3 upon 2. It will be interesting to see how we derive this. It's basically nc2 minus n. Now nc2 involves all the lines that are formed by joining any 2. It could be, this may include suppose there are 1, 2, 3, 4, 5, 6, 7, 8. So this nc2 includes all these sides as well as the diagonals. So from this, if you subtract the number of sides, that is nc2 minus n, you get the number of diagonals. So if you simplify this, this becomes n factorial upon 2 factorial into n minus 2 factorial minus n. If you take the LCM, this will turn out to be n factorial minus n into n minus 2 into 2 factorial upon 2 factorial, which is 2 into n minus 2. Now if you simplify this, this will become n into n minus 1 into n minus 2 and so on, minus n into n minus 2 into 2 factorial. Now so we have n into n minus 1 into n. Now in this, if you take n into n minus 2 factorial common, you end up getting n minus 1 minus 2. N into n minus 2 into n minus 1 into n minus 2. And here you have 2 into n minus 2 factorial. This gets cancelled. So ultimately it is n into n minus 3 upon 2. So the number of diagonals is n into n minus 3 upon 2. But just in case you're not able to remember the formula, you can use this. The number of diagonals will always be nc2 minus n. For example, in this case, it's going to be there are 10 sides. So decagon means there are 10 sides. So it's going to be 10, which means there are 10 points. So it's going to be 10c2 minus 10. 10c2 minus 10 is 10 factorial upon 2 factorial into 8 factorial minus 10, which will be 10 into 9 into 8 factorial upon 2 factorial into 8 factorial minus 10, which is 90 by 245 minus 10, which is turning out to be 35. So we can either use n into n minus 3 by 2, but just in case you forget this, we can use nc2. That is, 2 of them you're picking out of n number of non-collinear points. And since this includes even the number of sides, so to get the diagonal, you remove away the number of sides and you get 35. That is the number of diagonals. So among these, we have 35 as the formula, as the answer, sorry. So which is turning out to be 10c2 minus 10. Okay, furthermore, we have here, okay, this is a little different kind of a take we have here. There are 12 points in a plane of which 5 are collinear. The number of triangles are so and so. Now to form a triangle, we need 3 points out of 12. So ideally speaking, it's going to be 12c3 provided all the 12 are non-collinear, but out of which 5 are collinear. So you have to subtract the 3 that you have chosen out of the 5. So it's basically 12c3 minus 5c3. Which will give the number of triangles you have. 12c3 involves all the 3 sets of points, the sets of 3 points which you have taken, and 5c3 are removing the ones which are collinear, which will not form the triangle. So it's basically 12c3 minus 5c3, which is 12 factorial upon 3 factorial into 9 factorial, minus 5 factorial upon 2 factorial into 3 factorial. This will turn out to be 12 into 11 into 10 into 9 factorial upon 3 into 2, which is 3 factorial into 9 factorial. This gets cancelled. This will become 2 minus 5 into 4 into 3 factorial upon 2 into 3 factorial, which will be, so this turns out to be 220 minus 10. Which will turn out to be 210 diagonals. So 210 triangles can be formed out of these. If it had been told, just as a reminder, that 12 points in a plane of which, and this phrase has not been given, there are 12 points in a plane, none of 2 are collinear, then it means the number of triangles will just be 220. But out of these, 5 are collinear, so the 10 triangles that are 10 combinations of these 3 will not form the triangles, hence that has to be deleted. So the number of triangles formed is 210. And yes, we do have that 12c3 minus 5c3, which is 210. Okay, quite similar this, the number of triangles that can be formed by choosing the vertices from a set of 12 points. 12 points, so it's going to be 12c3. Out of which 7 lie on the same straight line. So it's 7c3. 12c3 minus 7c3. And if you calculate this much the same way as this, we are going to get 185 as the number of things, which is going to be just 12c3 minus 7c3. That is total number of groups of 3 that you have selected minus these ones, these groups of 3 which have been selected, which will not form triangles. That will give you 185. So both these sums were similar to each other, only the numbers have been changed. Furthermore, okay, much on the same way, the only thing is the unknown is different in this case. A polygon has 44 diagonals, then the number of its sides are so and so. Here it would make sense to use the formula n into n minus 3 upon 2 is 44. This would make sense. Or you can go ahead doing nc2 minus n, nc2 minus n will also give, but which will work out to be this. So which means that n squared minus 3n is equal to 88, which is n squared minus 3n minus 88 is 0. On solving, this gives, if you split the middle term, it will turn out to be n squared minus 11n plus 8n minus 88 is 0. This will give n as 11 or n as minus 8. This is of course inadmissible because we are taking the number of terms. So remember that n and r, whether it's permutation or combination, n and r have to be positive integers. So this is totally way out. So the correct answer is n is 11. So the number of sides is going to be 11, which also means that it has got 11 vertices. So one reminder, of course, a polygon, which means that a pentagon, hexagon, nonagon, dodecagon, anything where the number of sides is 4 or more is called a polygon. It could have 4 sides, a quadrilateral it is, or a pentagon, which means 5 sides, or a hexagon, which has got 6 sides, or a septagon or an octagon, nonagon, decagon, and so on and so forth. So anything which has got more than 4 sides, or including even 4 sides or more, is called a polygon. Let's see. So we got the number of sides as 11, and yes, we do have it as 11. Okay. Again, a building contractor needs 3 helpers and 10 men applying. How many ways can be selection? So out of 10 available out of 10 men, 3 helpers have to be chosen. So it's going to be 10C3, which is 10 factorial upon 3 factorial into 7 factorial, which is 10 into 9 into 8 into 7 factorial upon 3 factorial into 7 factorial. Now this is going to be 3 factorial is nothing but 2 into 3. This gets cancelled. So 3 3s are, 2 4s are. So it's going to be 4 into 3, 12 into 10, 120 selections, 120 possibilities can be derived out of selecting 3 helpers out of 10 available men who have applied. So our answer is 120, and yes, we do have it that way. Further ahead, we have cases, we have 6 seats of article clerks are vacant in a chartered accountant firm. How many different batches? So 6 seats are available out of 10. So the answer is going to be 10 C6 because you need to select 6 out of 10. So which will 10 C6, if you calculate it, it will work out to be 210, which is what we get over here. If you calculate that, it works out to 210, which is 10 C6. These are all very simple problems. So always, as I've been telling you, please keep a pencil and a paper in hand so that you can quickly get into the habit. If you see that you'll familiarize yourself, as I said, you need how to calculate 3 factorial. 3 factorial is always 6. 4 factorial is 25. So as you practice more and more, these numbers registers onto your head and you can save a lot of time. And remember, in an MCQ format, the most important thing that you need is save on time. Now, every time you cannot keep calculating 4 factorial. It's going to be 4 factorial is 24. We can take it as a standard thing. And this you can familiarize yourself only if you actually calculate and you keep repeating it yourself and you'll get it. Okay. So furthermore, we have, now here we have number of ways of painting a particular face of a cube by 6 colors. Now there is not much of thinking involved. It is just one, you have a cube and you already chosen a particular face. Say one, suppose you decided to paint this particular face, this one. And there are 6 colors available, which could be red, blue, green, yellow, orange, red, and maybe white. So what are the ways in which you can select? Obviously, there is only one face which you need to color, and there are 6 colors available. So out of you can select them in 6 different ways. So simple logic, which is possibly, the basic level of combination and permutation. So there are 6 ways in which you can paint a particular face of a cube by 6 colors. So it's 6. And yes, we do have it as 6. The next in line. Now, every 2 persons shake hands with each other in a party, and the total number of handshakes is 66. the number of guests in the party is what? Now here, suppose A shakes with B or B shakes with A. Both mean the same. So the order in which it happens, whether A shakes with B or B shakes with A, is not important. The order is not important, so what do we have? It is a combination or a permutation. Yes, when the order is not important, it is a combination. So we don't have a permutation. So basically, it means that it is handshake is between two people. So two people are shaking hands out of n of them, NC2, and this turns out to be 66. So NC2 turns out to be 66, which means that n factorial upon 2 factorial into n minus 2 factorial is 66. So in the next step, this n factorial can be written as n into n minus 1 into n minus 2 factorial upon n minus 2 factorial into 2. Now this 2 can be cross multiplied and you get 132. This gets cancelled. You get n square minus n minus 132 is 0. So splitting the middle term, if you take it, you will end up getting n as 12. If we solve this particular equation, it will be n square minus 12n plus 11n minus 132. So n will turn out to be 12. So the total number of guests obviously will be 12. So there are 12 guests in the party, in the particular party, and yes, we do have it as 12. Okay. Now here, what do we have here? At an election, there are 5 candidates and 3 members are to be elected. A voter is entitled to vote for any number of candidates not greater than the number to be elected. The number of ways a voter can choose to vote. That means each voter can choose to vote only for 1, or he may choose to vote for 2, or he may choose to vote for 3 members, all the 3. Yes, so unlike the usual national elections or the state level elections, we have a special kind of a case wherein a particular voter can even vote for 1, 2 or 3 number of candidates. So basically there are 3 possibilities. So either the voter votes for 1 out of 5, or, so the moment you have the concept of or, it is plus, it's not an and, or he votes for 2 out of 5, or he votes for 3 out of 5. But he cannot vote for anything more because the maximum number of members is 3. So it's 5C1 plus 5C2 plus 5C3. This will turn out to be 5 factorial upon r factorial 1, 5 minus 1, 4 factorial. 5 factorial upon 2 factorial, 5 minus 2, 3 factorial. This is going to be 5 factorial by 2 factorial into 3. Now both of them are same, both mean the same. Now this is going to be 5 into 4 factorial upon 4 factorial. This gets cancelled. This will be 5 into 4 into 3 factorial upon 2 factorial into 3 factorial. This gets cancelled. This will also become 10. Plus, again, this is going to be the same 5 into 4 into 3 factorial upon 2 into 3 factorial. This will also be 10. So it's 10 plus 10 plus 5, 25. So there are 25 ways in which a voter can choose to vote. So he could choose 1 out of 5 or 2 or 3. So considering all the possibilities, there are 25 such possibilities involving the ways in which he can vote, a particular voter. So our option is 25, and yes, we do have it as 25. Next coming is, okay, the Supreme Court has given a 6-3 decision upholding a lower court. The number of ways it can give a majority decision. Now, the Supreme Court has given a 6-3 decision. That means total number of available ways in which you need to vote is going to be 6 plus 3, 9. So, if you want a majority, we need to have at least 5. That means 5 of the votes have to be in favor, or 6 of the votes have to be in favor, or 7 of the votes have to be in favor, or 8 of the votes have to be in favor, or all 9 have to be in favor. Anything less than this would give a minority, and hence in that case we don't consider. So we consider only the majority when the number of votes in favor is going to be more than half of 9. So this gives you 9C5, which is going to be 9 factorial by 4 factorial upon 5 factorial, 9 factorial by 3 factorial into 6 factorial, plus 9 factorial by 2 factorial into 7 factorial, plus 9 factorial by 8 factorial into 1 factorial, and this in any case is going to be 1, but again just as a reminder, it's 9 factorial upon 9 factorial into 9 minus 9, 0 factorial. What does this turn out to be? 9 into 8 into 7 into 6 into 5 factorial. 4 can be written as 4 into 3 into 2 into 5 factorial. This gets cancelled, and here we have 3 and 2, and here we have 2, and then this would be 9 into 8 into 7 into 6 factorial upon 3 into 2 into 6 factorial. This gets cancelled. This will become 3, 4, and hence this will turn out to be 126. This is 84, and what do we have here? 9 factorial, so this would be 9 into 8 into 7 factorial upon 2 factorial into 7 factorial. This gets cancelled. 9 is at 72, and this would become 36. 36. This on simplification will become 8, and this will become 1. So we have 126 plus 84 plus 36 plus 8 plus 1. So many ways in which we can have a majority decision reversing the lower court. Let's see what we have here. It's 126 plus 84 plus 36 plus 8 plus 1, which will work out to be 200 and 1 sec. I think there's a mistake here. It's going to be 126 plus 84 plus 36 plus 8 plus 1. So we have 126 plus 84 plus 36 plus 8 plus 1, which turns out to be 255. We need to check whether we have made a mistake. Yeah, here. This is one. I'm sorry, there is a mistake we have done. 9 into 9 factorial by 8 factorial is 9 into 8 factorial upon 8 factorial. Hence, it is actually 9. It's going to be 9 plus 1. So, which will turn out to be 256, which turns out to be 256. 256. That is, among these you have 256 as the right answer. Now basically I just also wanted to explain what this means. Supreme Court has given a 6-3 decision upholding a lower court. Now what this actually means, that out of a total of 9 times, the Supreme Court has 6 times upheld the decision of the lower court. Means 6 times out of 9 it has approved the decision of the lower court. And now we are looking at a situation wherein what are the ways in which the Supreme Court would possibly nullify or reverse the lower court. So out of 9, as of such, 6-3 decision. So now it is a majority wherein it has upheld the lower court. Now what will be the reverse situation, whereas out of these 9 times, what are the possible ways in which suppose it does just the opposite, that is, it reverses the lower court's decision. So in that case, it is going to be, that's what it means. So it is possible that out of the 9 times, 5 times, the Supreme Court gives a ruling against the lower court, or out of 9 times, 6 times it could give a ruling against, or it could be out of 9 total number of times, 7 times it would give a ruling against the lower court, or 8 times it could give a ruling against the lower court, or all the 9 times it could give a ruling against the lower court, which is opposed to what it had actually done right now. So this is what this sum in general means. 6-3 decision. That means out of total number of 9 times, 6 times it has approved the decision of the lower court, and hence as per this we have 256 situations in which it can do the reverse. That is, it can do the reverse means it can go against the lower court and reverse the decision that it has made against the lower court. So there are 256 such possibilities. And yes, we do have it, that is 9C5 plus 9C6 plus 9C7 plus 9C8 plus 9C9. So these are the ways. This is one way of interpreting this particular question. Furthermore, we have a case. Okay, a Supreme Court bench consists of 5 judges, and how many ways the bench can give a majority decision. Now, how do you understand these questions? Now, all of you must have seen reality shows wherein there are about 3 to 4 judges who are deciding on a particular candidate whether he is suitable to be taken to the next level or no. So you may have 5 judges over here. So judge number 1, judge number 2, judge number 3, judge number 4, judge number 5. Now each of them, suppose there is a particular person who has been accused of murder. So the decision, so the person could say yes, the first judge could say yes, he is guilty, or no, he is not guilty, or yes or no, or the third person decides yes or no, or yes or no, or yes or no. Now you want, now it's in any kind of a situation, there is no single judge's opinion which solely matters. So it is a amalgamation or a collection of all the votes put together. How many of them are in favor? So you want a majority decision either in favor or yes or no, or yes or no. What are the ways in which it could be done? So how do we have a majority? Either out of the 5, 3 of the judges are in favor of a particular decision, either yes or no. So that means out of 5, there could be 3 who are in favor of it. Or instead of 3, 4 of them are in favor of a particular decision. I'm sorry, it should be 5C4. Or all 5 are in favor of a particular decision. We can relate to this kind of a situation often when you see reality shows. There are times when you have a unanimous decision taken or a standing ovation given, so which is absolutely non-controversial. All of them have accepted that this decision has to be taken. So anything lesser than this, that is 5C2 or 5C1, these are all called minority. So this is a minority decision because just one person or 2% is in favor of a particular decision. So they are minority, hence they will not be considered. We are talking about a majority division. So which means majority decision actually. So which means 5C3 plus 5C4 plus 5C5. Now 5C3 is 5 factorial by 2 factorial into 3 factorial. This would be 5 factorial upon 1 factorial into 4 factorial, and this is going to be 1. NCN is always 1. This will turn out to be 10. 5 into 4 into 3 factorial. This will turn out to be 5 plus 1, 10 plus 5, 15 plus 1, 16. And hence there are 16 ways in which the bench can give a majority decision. So, and we do have it as 16. So this is the way we understand. Comprehending the question is a very important situation. You just have 2 or 3 sentences, and hence we need to understand what the question actually wants. And often we need to read the lines 2 or 3 times to understand whether it is a permutation or combination. Remember, when it's about numbers to be arranged, the moment you have the words arrange or formation, which means it is an arrangement. If you're just selecting people for a committee or something, then it becomes a combination. Okay. Now here you have 5 bulbs, of which 3 are defective, are to be tried in 2 bulb points. So we have bulb number 1, bulb number 2, bulb number 3, bulb number 4, and bulb number 5. 5 bulbs, out of which 3 are defective. 1, 2, 3 are defective. Only 2 are. But you don't know which is defective because all of them look the same. It's only when you try, you will come to know whether they are defective or not. You need to choose. There are 2 bulb points. So you need to choose 2 bulbs out of these to be fitted. So it's going to be 5C2. That means you are selecting any one out of these, any two out of these, to light up the room. So it's told what are the chances that the room shall be lighted. But in this, there are also chances that the room will not be lighted. So you have to subtract the possibilities when the room will not be lighted. Suppose it is going to be this or this bulb. Definitely the room will not be lighted. That is 2 out of the 3 trials. If you take out of these, you definitely not involve the room getting lighted. So it's eventually going to be 5C2 minus 3C2, which is 5 factorial by 2 factorial into 3 factorial minus 3 factorial on 2 factorial into 1 factorial, which is, of course, will turn out to be 10 minus 3, which is 7. So basically, 5C2 involves all these. That is, any one of these bulb is chosen, any two of these, and they are fitted in the 2 sockets. So in these, a few of the trials may lead to lighting, may not lead. So this is not what we want. We have to remove the ones in which the room is not getting lighted. So it's as simple as that. The number of times the bulbs are tried, total number of times, minus the number of times the room is not lighted will give you the number of times the room is getting lighted. The number of times the room is getting lighted is total number of trials minus the trials in which the room is not lighted. That is turning out to be 10 minus 3, which is turning out to be 7. So there are 7 trials in which the room will definitely lead to getting lit. So yes, there is another way of doing it. Of course, one chance is that out of the 3 you have 1, 2 you have 1, or the chance or the possibility that none of the 3 of them and 2 of them are getting lit up. This is another way of doing the same thing. Either you take it as a total number of trials minus the number of trials which definitely not lead to getting lit. So yes, an answer is 7, and we do have it this way. 7 is the number of trials.